Alright, okay. Air pumps, chapter 11. Eh? What's your textbook? Chapter 11. Page 73. Alright, okay, guys. So it's air pumps. Now remember, we have different pumps that we can use to pump water. We have different pumps that we can use. If you check from that textbook, it gives you different pumps that we have. There is what we call the Edward air pump, which is on page 73, and then there is the rotating air pump, and then you also have the air ejector pump. So those are different type of pumps that you must also know them. But mostly, you know, with power, most of the theory they don't like to ask theory. But you must know the different type of pumps that we have. And then these are the formulas which goes with what? With air pump. So you must know, and some of the formulas that they're on your formula sheet, but some they are not given. So please make sure you confirm which formulas are given and which one are not given. Alright, okay. So the first formula that we have is to calculate the condenser efficiency. So if they want you to calculate the condenser efficiency, it's gonna be what? T2 minus T1 divided by Ts minus T1. Alright, okay. You know what by your T2 is what? Is the final temperature, and then T1 is the initial temperature, and then your Ts, I said, is what? The saturated temperature. Alright, okay. And then you also have the formula to calculate what we call the vacuum of what? The vacuum efficiency is just gonna be the partial pressure of the what? Of the steam. And remember, I said if you are not given the pressure of the what? Of the steam, you can get it on the steam table using what? The temperature. And then the absolute pressure of the what? Of the condenser. And if they're talking about the absolute pressure of the condenser, just like the pressure of the what? Of the air. Alright, okay. And these are the formula that we're talking about on chapter 10. If you still remember, these two for calculating the total pressure. I said that you can use these two formulas, whereby the first one you're given the barometer and vacuum. Yes. So it's gonna be the barometer minus the vacuum, close the bracket, 0, multiplied by 0,1133. Or you can use the second one, whereby you're given the pressure of the air and also the pressure of the what? Of the steam. And I said if you don't have the pressure of the steam, you can get it at the given temperature on the steam table. And then you also have the formula to calculate what we call the logarithmic mean temperature difference. Okay, and your formula is just going to be theta m is equal to theta 1 minus theta 2 divided by ln theta 1 over theta 2. And how do you get your theta 1? They call it the temperature difference at what? At water fluid inlet. That is your theta 1. And how do you get it? It's going to be Tc minus T1. And this is the saturated temperature. You can get it at the given pressure on your steam table. And then T1 is the inlet temperature. Same thing when they're talking about now the temperature difference at your water fluid outlet, it's going to be, I didn't write it down. I think I left something here on this, guys. It's going to be Tc minus T2. Please, can you just also add on that? Yes, it's Tc. Tc minus T2 on this, I forgot to write it. Okay, which is what? Your saturation temperature minus what? Minus the output temperature, or the outlet temperature. And then you also have the formula to calculate what we call the surface area. And then they're saying the formula to calculate the surface area is going to be the heat transfer divided by the overall heat transfer coefficient, multiplied by your mean temperature. And you know you can calculate your mean temperature using this formula. And remember, I said on heat, I think it's chapter 8. I said you have the formula that you use for heat. There is heat when you are heating water, when you are heating what? When you are heating let's say steam, and also when you are heating what? A fuel. Yeah, so those formulas to calculate your heat, which is key, is different, guys. You must know the formula to calculate when it is the heat of a steam, when it is heat of a fuel, and when it is the heat of what? Of your water. Alright, and I have already done that. Okay, and then you also have the formula to calculate what we call the area of what? Of water flow. It's gonna be the area multiplied by the number of what? Number of tubes. If you're not given the number of tubes, you can just calculate the number of tubes using which formula? This formula. And these two formulas, please note, they're not given on your formula sheet. This one you must know them. Alright, okay, let's try to do something on page 79. Exercise 11.5. Exercise 11.5. So also on this, yes, you must use the steam table. Do you see that it also has the heat? Ne? So whenever you're dealing with the heat, you must also use the steam table. So make sure you request for the steam table whenever you're doing your power, on your power exam. Ne? You must use the steam table. Okay, exercise 11.5. So not exercise, example. Ne? Example 11.5. We are all there? Okay. Let us write the given information. They're saying a surface condenser dealing with 25,000 kg steam per hour. Ne? So I'm given the mass of a steam which is given per hour. Ne? I'm given the mass of a steam which is 25,000 kgs per hour. Ne? Okay, and I'm also given 0.91 dry, which is the dryness fraction. 0.991. They're saying at a pressure of what? 5.5 kilopascals. Thank you. And then they're saying is the absolute pressure. Eh? They're saying condensed to the steam to a water at 32.9. Eh? So that temperature is what? The temperature of the what? Of the water. Eh? Alright, okay. Temperature of the water, which is 32.9 degrees Celsius. Alright, okay. They're saying the cooling water is heated from 15 degrees Celsius to 25 degrees Celsius, which means I'm given T1 and what?
T2.
And T2. Ne? T1. And then I have T2, which is 25 degrees Celsius. Okay, they're saying it's passing through the condenser if the coefficient of heat transfer is what? I'm given the coefficient of heat transfer. The coefficient of heat transfer, which is what? Which is U. Which is 3890 kilojoules per meter squared degrees Celsius. Ne? Okay, I'm giving you. What else am I given? They think determine the surface area of the what? Determine the surface area required. They need us to calculate the surface area. So which formula I'm going to use to calculate the surface area, guys? I have this one. Eh? Okay, so the formula to calculate the surface area says Q divided by U multiplied by theta AM. Ne? Alright, okay, let us see. I'm only given U. Ne? I don't have Q, which is the heat. I also don't have what? Theta AM. Ne? So which means I have to calculate the heat. And what do you know about this? About the heat? Which heat are we going to use? Remember, I said you have three formulas. You have the heat of the what? Of the steam. You have the heat of the what? Of the fuel and also of the water. They said a surface condenser dealing with what? With 25,000 kgs of steam. Ne? So we are talking about the steam. Yeah. So which means if I'm calculating my heat, it must be the heat of the what? Of the steam. Ne? Alright, okay. So what is the formula to calculate the heat of the steam, guys? If you can still remember. If you can still remember, what is the formula to calculate the heat of a steam? I said it's what? It's MS H2 minus H1. Eh? Alright, okay. And then remember, what did I say? I said your H2, it is gonna be the what? The enthalpy. It depends with the enthalpy which is given. Eh? And then your H1, you take it as HF at the given what? At the given temperature. Eh? The same thing that we're doing on the previous one. Okay. So I'm given my mass. Now my H2, I don't know which enthalpy is it. And I have to check with the given information. And I remember I said, whenever they give you a pressure what? And the dryness fraction, you know it's the enthalpy of what? Of a weight. When they give you a pressure and a temperature, you know it's what? It's a superheated. Eh? But on this case, I'm given what? I'm given the dryness fraction and I'm given what? The pressure. So I know my enthalpy is going to be the enthalpy of what? Of a weight. Nah? Okay. So which makes my formula to be the what? The mass of the steam. What is the formula to calculate the enthalpy of a weight? I said it says HF plus X HFG minus your H1 at the given temperature. Okay. Let's do like this. Okay, so let us calculate our. I'm going to get my HF at the given what? At the given pressure of 5.5 kilo pascals, and also my HF G. Can you please check on the steam table for me? Can you please check on the steam table?
Check.
This one is what? 145 kilojoules per kg, and then HFG?
At 5.5 pressure.
Yes.
2420.
2420 kilojoules per kg. Ne? And remember, I said you also want what? You're going to get your H1 same as what is HC, same as HF at the given what? Temperature. Ne?
Yeah.
So HF, and which temperature? Remember, I said use the saturation temperature, ne?
Yes.
Which is the temperature of the water. Do you see this one? I'm given the temperature. And remember, I said if they don't give you this temperature, you can use the outlet of what? Of this two. Ne? But in this case, I'm given the temperature of what? Of the water. So which means I'm going to get it at this HF at 32.9 degrees Celsius. Check for me. It's what? 138. Ne? Okay, it's fine. So now I can calculate my Q. Let me just use here with the space. What was my mass? It's 25,000. Open bracket, and then my HF is 145. Okay, plus X, which is 0.91. Okay, multiplied by 242. Okay, and then minus. So my HF is 1. So guys, remember I said you can put two brackets, né? Okay, can you please use also this brackets, né?
Yes.
This one you open two brackets, this one inside this bracket, and so it will give you the correct answer. Because last time I was getting, please use just put as it is on this on the board. Listen what I'm getting?
Is it minus 13.8?
Minus, no, 138, no. 138, minus 138. What are you getting?
5. Yeah.
Yeah, 5.
5.
55,23 multiplied by 10 to the power 6.
It's what?
55,
2,
comma 23
23
times 10.
times
Is the
10.
engine?
Yeah.
The power?
To the 6.
The power 6, no?
Yeah.
Alright, okay, it's fine. You can even write it like that. Okay? And then it's kilo. Just, and remember, I didn't, the reason why it's too big, I didn't change my mass, ne? So I know it's per hour, ne? Because I didn't change my mass. Alright, okay, it's fine. And then so now, which means now I have my Q. What else do I need here? What else do I need here? I also need my theta M, ne? And how do we calculate my theta M? I said this is the formula, ne? You have to find your theta 1 and what? And theta 2. And how do I get my theta 1? Theta 1, we say is what? Is Tc minus T1, ne? What is your Tc? Is the temperature of what?
Yes.
Of the water, ne? Which is 32.9 minus T1, which is 15. What do you get? 32.9 minus 15.
17,9.
17.9.
degrees Celsius, ne? And then I also can get my theta 2, which is 32.9 minus 25.
7,9.
7.9 degrees Celsius, ne? So it means now I can calculate my theta M, which is theta 1 of 17.9 minus 7.9 divided by ln of what?
of 17,9 divided by 7,9. Can you please punch and give me an answer here?
Twelve comma 26.
4,226.
Yeah.
Alright, okay. Degrees Celsius. So now I have my theta m and I also have my q. Alright, okay, which means now I can calculate my area. Ne? So my area is gonna be my q. It's 5, 5, 2, 3 times 10 to the power 6 divided by my u, which is 3890 multiplied by 12,26. Can you please multiply this for me? Then you build your area. What are you getting?
1,
1, 1,
5, 8.
1, 1, 5, 8.
1 comma 158.
1 comma
158.
sorry. 1,158
8 times 10 to the power 3.
and 10
It's a
like this. Alright, okay, so you mean this is your final answer, ne? Alright, okay. So please, you have to check which formulas you are given on the formula sheet and which formulas are you not given on the formula sheet. Ne?
Yes.
Alright, okay. So you can even write it. Can you please just give me as it is besides times 10 to the power 3? Ne?
1158, 0.
It's 1158, comma
071.
071 meter cubed, because it's in area. You can just.
Oh, because what? Yeah.
Okay, what I saw on the textbook, they get 1170, comma 2. Ne? I think it's because of this. On this one, we get a different answer. Ne? I'm not sure what it. Let us see. Maybe it's a matter of running over. So basically, guys, this is how you do it. Ne? So please, you must familiarize yourself with the formulas. Ne?
It's a page of one.